Okay, let's now move on to what I'm calling split the middle. Some of you may have learned factoring with this X method. I've heard diamond method. They're all pretty much the same process. Sometimes they're called something different. One thing I did forget to mention at the top is whenever we factor, we always look for the greatest common factor, the GCF, first, if we can factor it out. So I didn't have a GCF on any of these. I couldn't divide a number or variable out. But that's what you always want to check for that first, because that will help reduce, of course, the size of your numbers and make guessing and checking easier. Okay, split the middle. We are wanting to, the goal of this, or the X method, however you want to call it, is to split this middle term up into two terms. Now, the reason you might use split the middle is it is an alternative to guessing and checking when A is greater than 1. So when A is less than 1, you want to guess and check. When A is greater than 1, guessing and checking is a method. Split the middle is another way to do factoring. So I want to multiply the A value and the C value and put it in the top here. I want to write the B value down here. So if I take the A value, which is 6, the C value, which is, 3, and negative 6, and multiply those, I get negative 18. B value is negative 7. So I am searching for factors of negative 18. So multiplication, factors that multiply up to negative 18, but add up to negative 7. So again, here's where I would list my factors out. So factors of, and I'm going to ignore the negative for just a moment, factors of 18. 1 times 18. 2 goes into 18, 2 and 9. 3 goes into 18, 3 times 6. Of course, 3 and 6 are getting pretty close. 4 doesn't work, 5 doesn't work, and we are finished. So now bring the negative in. I want numbers that are going to multiply up to negative 18, but add up to negative 7. So I'm searching for values, or terms that add up to negative 7 here. 9 and 2. 9 minus 2 is 7, but if I make the 9 negative and the 2 positive, that'll add up to a negative 7. So the larger factor drives the sign on the answer when you add or subtract. They also multiply up to negative 18. So I'm going to put a 2 here and a negative 9. So we are going to rewrite this problem, and we are going to split the middle term into 2x and negative 9x. So I have 3x squared plus 2x minus 9x minus 6. Okay, so I have just split negative 7 into 2 and negative 9. All right, now we are going to group. There are four terms. We are going to group sets of 2 terms together. So I'm going to look at 3x squared plus 2x for a moment, negative 9x minus 6x. So we want to individually factor the GCF out of those 2 terms. So when I look at 3 and 2, I can't factor a number out of either of those bigger than 1, but I can factor an x. There are 2 of them here, there's only 1 here. So I'm going to factor out an x, and then I'm going to divide it out and then write what's left. So I would be left with 3x plus 2. Okay? Now, whatever the sign is here, it drops down to the next step. And I also want to do GCF here. So between 9 and 6, I can remove a 3, but I can't factor an x out because there's no x on the 6. So I'm going to factor out a negative 3. So now when I divide, negative 9x divided by negative 3 leaves me with 3x. Negative 6 divided by negative 3 is positive 2. Now, I want you to notice that these 2 terms are the same. If you have split the middle, done the X method, the diamond method, however you want to look at it, you should always get these 2 terms to match. If you don't, you have made probably an error on your factoring out your greatest common factor. So now what I want to do is I want to look at this as a set of terms, this as a set of terms, and I'm going to factor this common term out. So I now have 3x plus 2, and once I have factored that out, I'm left with x minus 3. That is my other term. Okay, and so that is a split the middle type of a method. So it does get me to the same type of an answer. Guessing and checking is one method. Split the middle is more of a procedural step. Okay, so it's really kind of personal preference. The goal for advanced geometry is that you can factor. That's really what you want to do. Okay, I want you to pause, do the second one next to it, do split the middle, write your steps out this way, do guess and check, or just factor how you're comfortable factoring, and then come back. Okay, I'm going to, I guess I'll split the middle here again. So I want to, and I'll situate my work like this, A times C and B. So 3 and 7 is 21, and then negative 10. So I'm looking for factors of 21 that add up to negative 10. So 1 times 21, only 2 sets of factors. To get them to add to a negative 10, I want to make them both negative, and then when they multiply, it'll keep 21 positive. So I have a negative 3, negative 7. All right, split the middle. So 3v squared minus 3v minus 7v plus 7. So let's group. So I'm going to view these two and then those two. Okay, I can factor a 3 and a v. So 3v, and I'm left with v minus 1. Bring the negative down. I can factor a 7. I'm left with v minus 1. And I got these to match, so I did my GCFs correctly. Now I either think of it as regrouping or factoring out. So I'm going to factor out this v minus 1, and then I'm left with 3v minus 7. Okay. All right, one more. At the bottom here, if you want to pause it and do it, you can. This does have a GCF in it. I can tell 6, 40, and 14. I can at least divide a 2 out, maybe something larger. So that's where we want to start here. GCF. Okay, so let's factor out, looks like just a 2. Sometimes you can also factor a variable out. All right, factor a 2 out, so I'm left with 3x squared plus 20x. That would be minus 7. Okay, you can pause. You can do this on your own, split the middle. I'm going to guess and check here. So this 2 will just drop down and be part of the answer. So now I am really just focused on the trinomial that is left here. So I'm going to guess and check. I'm going to switch to pencil because I probably will have to erase. All right, factors of 7, just one factor, 1 and 7. Factors of 3, again, just 1 and 3. So actually, this is a good one to guess and check on. So I'm going to have my x times 3x. I'm just going to go with 1 and 7. Let's see if it's going to work. 1 and 7. All right, so I'm going to check. Do the middle 2 terms multiplied together plus the outer 2, can I get it to say 20? 3x, 7x. No, that's either going to be a 10 or a 4. So now I want to switch the 1 and the 7. So this is why I use pencil. Let me get rid of these. I am going to put the 7 and the 1. And the more you do this, you may not need to write it and switch it. You might be able to think through the multiplication. I always write it down. It's just easier for me as I work through it. So 7 times 3, 21. 1 times x is 1. Okay, I can make this say 20. So I want it to be positive. So if I keep the 21 positive and I make the 1 negative, that'll be 20. So the 21 came out of 7 times 3, so I'm going to make it plus 7 minus 1. Okay, let me clean this up just a little bit. I'm going to bring back in, this 2 needs to be in front. Okay, I'll just copy over this so it shows up a little bit better. And then here is your final factored answer. Okay, so again, alternative to box method, or alternative, excuse me, to split the middle. Box method is another method you could factor with. Like I said, there's a whole host of methods. I just want you to pick one and be able to factor. Okay, let's finish up with special cases. So special cases, this one's called difference of squares. Notice I just have the A term and the C term. A term, C term. A term, and C term. So I have, all of these are subtraction signs. So again, first, is there a GCF? No GCF here. Now when I recognize these, the A value and the C value are perfect squares. So remember, a perfect square is the result of a value or variable multiplied by itself. So this is a perfect square because x times x is x squared. 16 is a perfect square because 4 times 4 is 16. Okay, so this is called difference of squares. Difference of squares. And then, so if you know your perfect squares, these are super fast to factor. Now, the way to make the B value disappear is when I'm going to have one factor have a positive sign in it, one factor have a negative. So let's set up our factors. So it's going to be x times x, because that's going to multiply up to x squared. 4 times 4 is 16. And if I make one term positive and one term negative, when I multiply that back out, the middle term goes away. So let me just show you real quick. This is our answer. I'm going to circle it, but let me just show you or remind you how that middle term goes away. So when I multiply this out, x times x is x squared. X times negative 4x is negative 4x. 4 times x is a positive 4x. 4 times negative 4 is a negative 16. See how those two add up to 0. Okay, second one. I cannot factor a GCF out, but 2x times 2x is 4x squared. 11 times 11 is 121. 2x, 2x. 11, 11, the B value drops out, one factor is positive, one factor is negative, and you're done. Okay, so difference of squares are good to see because you can factor quickly. These are not perfect squares, but there's a GCF. There is a 10 I can factor out. So let's factor the 10 out. X squared minus 4. Perfect square, perfect square. Okay, so I bring the 10 down. That is part of your solution. X times x gives me x squared. 2 times 2 is 4. 1 positive, 1 negative to make it drop out, and that is your solution. Okay, if you have any questions, let me know. Or if you want to go over a different method of factoring with me, just to double check, that would be fine too.